This video we're going to talk about section 7.7, trig relationships. So recall the unit circle. You can see it here in the yellow. It's a circle centered at the origin with radius 1, and its equation is given by x squared plus y squared equals 1. Now we know that if we draw our angle theta that you see in blue, and it could be in any quadrant, it doesn't matter, then the x and y coordinates of that point on the unit circle, where the terminal side of the angle intersects the circle, is the cosine of that angle theta and the sine of that angle theta. So because that x is cosine of theta and that y is sine of theta, if we plug those into our equation, we get cosine squared of theta, cosine theta squared plus sine of theta squared must also equal 1. So we have an efficient way of writing sine squared and cosine squared. Instead of having to use the parentheses, we can put the exponent 2 above the n so that we know that we're taking the sine of theta first and then multiplying that result times itself. And so this we call our Pythagorean identity, because as you can see, it is really just coming from the Pythagorean theorem. So you can do this like on your calculator. If you take, say, the sine of 37 degrees squared plus the cosine of 37 degrees squared, you'll see it really does in fact equal 1. So it works for any angle. So we can see this graphically. It's kind of neat to see on your graphing calculator. If you put your calculator, make sure you're in radian mode. If you put y1 equals sine of theta and y2 equals cosine of theta, then for y3 you can say y1 squared plus y2 squared. You'll get the graph that you see here, where the green curve is the sine curve and the blue curve is the cosine curve, and the red curve, which is always just y equals 1, is that sine squared plus cosine squared. Kind of a powerful little thing to see, I think. Now we have some new trig functions that we want to define here. So we call the secant of theta. So the name is secant, and we abbreviate it as sec theta, is the reciprocal of cosine theta. It's 1 over cosine theta. And the cosecant, which we abbreviate CSC, is given as the reciprocal of sine. So it's 1 over the sine of theta. So we know then everything is defined in terms of sine theta and cosine theta. So we have 3 different ways that we can come up with sine theta and cosine theta, and then we know that the other 4 trig functions can be defined in terms of sine and cosine. So there you have it. Now let's see if we can graph these new functions, cosecant and secant. So I think you're going to like this a little bit better. To graph cosecant first, we're going to think of it as 1 over sine theta. So what we're going to do first is graph our sine curve. So we know what that looks like. It's got high and low of -1 and to 1, and we're going to put our critical points every pi over 2. We know the period of our sine curve is 2 pi. I'm going to go a full period to the left and to the right just so we can see it and get an idea of what that's going to look like. We're going to compare it and contrast it to our secant curve. So I'm going to plot these points. Now sine, we know, starts in the middle, and then it's going to go high, low, middle, low, back to middle, and similarly this way. Now some people will just graph these points that I'm doing here when they're graphing the cosecant. Others will make this a dotted curve. I'm going to go ahead, because I have different colors, I'm going to put this one in blue, and we're going to see how we're going to use this curve in a moment to come up with our cosecant graph. So there's 2 full periods of the sine curve. Now we know that our cosecant is 1 over sine, so any place the sine is equal to 0, our cosecant is going to be undefined. These are going to be vertical asymptotes. So at every multiple of pi, we're going to get a vertical asymptote in the cosecant graph. Now, when we look at the high and low points for the sine curve, I'm going to do this curve, I think. I'll make it in green. So when you share this point right here, where the sine of pi over 2 is 1, then our cosecant is 1 over 1, which is also 1. So I'm going to use the words we share the high point. Now, as we work our way going towards the right here, these sine values are getting smaller and smaller, but they're still positive. So as we divide 1, which is just always 1, by a smaller and smaller number, dividing by a small number gives us a bigger and bigger number. So it's going to go to infinity. Similarly, as we work our way to the left towards the y-axis, this is going to blow up and go to positive infinity. So I'm going to say it shares the cosecant curve shares the high point with sine and then goes up to those asymptotes. Similarly, where the sine is equal to -1, then our cosecant is going to be 1 over -1, which is -1. So they're going to share that point. As the sine curve gets closer and closer to 0, we're dividing by a smaller and smaller negative number, and so it's going to take off and go to negative infinity. And similarly on this side. And then it's going to repeat itself over and over again. So sharing the low point going down, sharing the high point going up. So you can see that to get one complete period, one complete cycle, we need that part that goes up and the part that goes down. So the period for our cosecant curve is also 2 pi. Now the amplitude doesn't make any sense, again, because there is no highest or lowest point. What's interesting and kind of crazy is the range of this. You can see that the range of our cosecant curve is going to be y for range, y greater than or equal to 1, or y less than or equal to -1. And you will see that sometimes written correctly as the absolute value of y is greater than or equal to 1. So there's that kind of gap in the middle there where that cosecant curve doesn't have any y values between -1 and 1. So in a similar fashion, we're going to graph our cosecant, but I'm going to now graph the cosine curve first. So there's going to be pi over 2, pi, 3, pi over 2, 2 pi. We're going to have 1 and -1 on the y values, and we'll also go to -2 pi to the left. So negative pi over 2, negative pi, -3 pi over 2, and -2 pi. Now a cosine curve, remember, starts big, then we're going to go to the middle, down to a low point, to the middle, and finish back up there. And similarly going to the left. And so we'll get, this is our cosine curve for 2 full periods. Now as we saw before with the sine curve, when the cosine is 0, those x-intercepts are going to be vertical asymptotes for our secant curve. So you can see that it's at the over 2's, whereas the cosecant curve has the vertical asymptotes at the multiples of pi. And then in a similar fashion, we're going to share the high point. I'm going to pick a different color here. Share the high point and go up, and share the low point and go down. I think it looks kind of cool when you get that kind of half period at the end, but that's just me. So you're going to get something like this. So you can see here as well, the period is going to be 2 pi, and there is no amplitude. And when we graph these, even when they get all the complications that we're going to see in a moment, our translations, our stretches and shrinks, and our reflections, we're going to just first graph the sine or cosine curve and then use that to get the actual secant or cosecant. So let's see what this looks like. So I'm going to start here, and let's see, I'm going to do this in yellow. So we're going to factor this out first. So we'll take the 1/2 out, and when you factor out a 1/2, to divide by 1/2 is to multiply by 2. That's going to become pi over 3. So we're going to actually graph here our cosecant. And first I'm going to graph the sine curve. So our period is going to be the natural period, 2 pi, divided by that 1/2 is going to be 4 pi. Our tick marks are going to be every fourth of a period, which means every pi. We're going to start at pi over 3, so I'm going to call this pi over 3, and then the next tick mark will be pi added to that, and 1 pi is 3/3, so I'm going to call that 4 pi over 3, and then I'm going to go 7 pi over 3. Now I could keep going, but I about run off, so I'm going to go back the other way. So this is going to be, if I subtract 3/3 from 1/3, that's going to be a negative 2 pi over 3. And then this is going to be a negative 5 pi over 3. Okay, so I'm going to graph this. I think I'll do it in green here. So our sine curve is going to start in the middle at pi over 3, and middle for us is going to be at 1. So I'm going to call that 1, and our amplitude for the sine curve is going to be 2. So I'm going to need to go up and down to up to 3 and down to -1 for the sine curve. So sine in the middle is going to be right here. Because it's a negative sine curve, we're going to go down first. So that's going to put us here and then back to the middle. And I'm going to go to the left. So that's going to go up to 3 and then down to the middle. So here is our sine curve, which we are going to use to graph our cosecant. So the places we have vertical asymptotes would be where we cross the midline. That's our translated x-axis. Those would have been our x-intercepts if we weren't translating it. We're going to share the high point and go up, and share the low point and go down. Okay, there you have it. Let's do one with our secant curve. So I think I'll do this one in, I think I'll go red first. So we're going to factor out the pi over 4, making that x minus 1. So our period is going to be 2 pi over 4, which is going to be 2 pi times 4 over pi, which is going to be 8. So our period is 8. Our tick marks are going to be every 2, and we're going to start at 1. So there's going to be 1. I'm going to label that down here, and then we're going to go 3, and then 5, 7, I'm going to go to 9 there. Let me extend that a little bit. Okay, so our midline is going to be at -1. So there's going to be -1. And our amplitude for the cosine curve is 3. So I'm going to go down 3 and up 3. And a cosine curve is going to start big. So a cosine curve is going to be at 1, we're going to be all the way up here. At 3, we're going to be in the middle. At 5, we're going to be at that low point. At 7, we're back to the middle. And at 9, we're back to a high point. So here is our cosine curve. And then the actual secant curve, we're going to have asymptotes where when we cross our midline, it's going to be at 3 and at 7. And we are going to share the high point and go up, and share the low point and go down, and share a high point, go up. So there's one full cycle of a secant curve. Very good.